Okay, cool. All right. Well, you are working on chapter 3, right?
Yes.
All right. And you were asking about do you want to talk about the discussion first or just the normal distribution or what were you thinking?
I'm having trouble with the discussion, working with the StatCrunch normal calculator. I'm
Okay.
having trouble calculating the percentile rate. I'm not sure
Sure.
how to do that.
Cool. Well, this is like yeah, this is really good that you're working on that particular thing. That's one of the thing you're doing right now, finding z-scores and p-values is something we'll do the rest of the course. So this is a relevant thing. So how about this? How about if I just share my screen and I'll just we'll just look at the discussion and then I'll just kind of walk you through a few things. How's that?
It sounds
So
good.
let me go back here. Let me give me a few things loaded before I share the screen. So I'm just going to go into chapter 3 here. All right, and let's go ahead and put this over here. There we go. And all right, so I'm going to and go ahead and load StatCrunch if you would. I have
Okay.
that open as well. All right. All right. Now I will share my screen. Cool. There we go. All right. Can you see that okay?
Yes.
All right. So I don't know if you've seen this little, it says StatCrunch tour. That's kind of a helpful, little video on how to do a lot of the stuff, load the data from your online homework and do a few things like sample statistics. But what you're doing that is that normal calculator stuff, and that's very relevant to what we're going to be doing here. And I think I'm going to scroll down here. There it is. Okay, so there's a discussion. So what you're supposed to do is take your sample that you found from the one used for chapter 1 and chapter 2 discussion, your sample of 30, and use that mean and standard deviation of that sample as kind of like your source. So, and then you pick a famous person or just anybody or yourself, it doesn't matter. Did you have someone in mind that you wanted to pick?
Yeah, I'm just using the example person from the discussion of Anthony Hopkins.
Okay, cool. And so you can look up his weight, and it says on here it's 180. Maybe it's changed. You can maybe Google it again to see if they've updated it. Um, so really, you're just going to compare a person to the sample mean and standard deviation. So do you see this formula? Z equals x minus x bar over s.
Yes.
So x is the data point. So if it's 180 or whatever the person is, x bar is that sample mean from your group of 30, and s is your sample standard deviation. Um, just a note, if it's using English like x and s, it's talking about samples. If it's using Greek symbols, it's talking about population. And you're also going to be doing that in this chapter. Like they're going to say the average male in America is this hot, or it's a population mean, and that would be sigma for the standard deviation, population standard deviation, and then mu. That's not on this one, but it's the same formula, essentially, same concept. But this is a good way of introducing you on how to find a z-score. And a z-score is just describing essentially how far away is that data point from the mean? How far away is it from the middle? And then to describe, like, instead of saying it's like, oh, it's 10 pounds away or whatever it ends up being, it's saying, how about how many standard deviations is it away? How many of those? So we're using that standard deviation kind of like a ruler. Like, how many of those is it away? So should we go ahead and calculate your z-score for this one? Do you remember, did
Yes,
you do the sample mean and standard deviation? Do you have that already?
I do.
Okay, cool. So how about you go ahead and just kind of tell me so we're going to use, are we using 180 then for the x?
Yes.
Okay, so we got 180 minus, and what was your sample mean for yours?
176.8.
Cool. And then what was your standard deviation?
It was 36.239053.
Okay, so pretty big spread, sounds like, of weights.
Yeah.
Your sample. So you're just going to take 180 minus 176.8, you said?
Yes.
So that's what, 3.2?
Yes.
So he's 3.2 pounds above that mean, and then you divide it by the standard deviation, which is, would you say 36 point something?
Yeah.
Cool. And so you're going to get like 0.1 or something like that. What do you get?
I got 0.088.
Okay. So almost right in the middle, isn't he? And
Yeah.
so if it's a positive z-score, that means, well, he's above average, barely, right? If it's a negative z-score, then that's below average. So now that you have the z-score, you have a description of how far away Anthony Hopkins is from your mean. But you want to know the percentile rank, right? Like, where does that rank? So this is where we're going to go to
Right.
Stat. So let's go to Stat Crunch, and let's go to Stat Calculators, and let's go down to the normal calculator. How's that look?
I see. Yeah.
All right. So what I would recommend is when you have a z-score, you already have what we'd call the standard normal distribution. You're just going to say, we're assuming that weights are normally distributed, and we can just use this one with an average of 0 and a standard deviation of 1. This is the standard normal distribution. So you could type in your z-score right here and get the percentile rank. That means the area to the left. And what was yours again? 0.08?
0.88.
88, and then hit compute. So Anthony Hopkins would be about in the 53rd or 54th percentile right in there. So that means
Okay.
about 53.5% of the population weighs less than him. So that's the powerful thing about this, is the finding a z-score and using the standard normal distribution, is it doesn't matter what, like if you're talking about weights or heights or IQs or ACT, whatever it is, whatever it's normally distributed, once you find that z-score, you can just use this distribution. Now this calculator is powerful though. You can use it just straight on. So let's just do it exactly like what we did. Like, we know the mean of your group was what, 176.7? Is that what it was?
Let's see. Yes.
Was that your sample? Yeah. And your standard deviation was what again?
36.23803.
Yeah, it's probably closer than we need to, but we can go very accurately, right?
Yeah.
And then you can say, all right, Anthony Hopkins, what's less than 180, and hit compute. And essentially we get the same thing. Now this one actually might be a little more accurate because we carried it out more digits potentially, but you get the idea. So you can, I don't recommend using this method because in chapter 6, we're going to start using the central limit theorem. So instead of looking at one piece of data, we're going to look at the average of a group, and the size of that group matters, which will then affect the standard error. And you can't just type it right into here. You have to use a z-score. So I know I do have some people that do this on this discussion, and I accept it. But by the time chapter 6 rolls around, that method doesn't work anymore, because now we're looking at group means, which is really what we're going to be doing the rest of the course after that. So I would recommend doing like we did the first time. Just go ahead, find your actual z-score, and let the mean be 0 and the standard deviation be 1. So you're using the standard normal.
Okay.
And then type your. So let's say I weigh 200, and I just got on the scale. I'm 205 pounds. All right. So what would my z-score be? Can you do that really quick? So take 205 minus 176.7, and then take that difference, and then divide that difference by your standard deviation, and what z-score do you get?
Okay, let's see. Get my calculator.
I thank you for doing that.
Okay, so the difference is 28.2, and I divide
Okay.
that by my z-score.
Yep.
So that would be 0.775 or so.
So I'm going to go ahead and put that z-score in 0.77, you said, right? And hit
Yeah.
compute. So that means I would be, referencing against your sample, I would be in the 78th percentile, right?
Right.
If I wanted to find out what percent are above, I can just flip the inequality. So that means about almost 22% are heavier, right? If according to that, if they're all normally distributed. You can even hit this between button. Like how about what's between me and Anthony Hopkins, right? So I could put, he was at what, 0.08 something? Let's give it at that. And I was at 0.76-ish, just to show you what, so it'll actually find there's about 25% between us. Is that cool?
That's interesting. Yeah.
So we're going to use this tool the rest of the course. So anytime you have a z-score, you'll probably be using this calculator. The thing I like about it, it gives you a picture of what you're doing, so you kind of like understand, am I doing left, am I doing right, am I doing between? You've got the options, and the cool thing is, like, what if I wanted to find out what's the z-score for the top, I don't know, or let's say the bottom 5%. So watch this. If I just hit standard and I want the percentage to be 0.05, I can hit compute. That would be, so this would be 1.64 standard deviations above normal is the cutoff for the top 5%. If I go less than and I put in 0.05, there's the cutoff for the bottom 5%, 1.64 standard deviations below. So and when you get to the last section of this chapter, it will ask you a few questions like this. It'll say, hey, what's the cutoff for the bottom 5%? Well, in that case, you can use this calculator to find the z-score, right?
Right.
So if I go back to my formula here, if I know this z-score and I know the mean and I know the standard deviation, what's the only thing I don't know?
We need to know the percentile.
Well, yeah. So if we say the cutoff for the bottom 5% is equal to negative 1.64, right? So you could put negative 1.64 in there. Let's see if it'll let me do this. Let's see if it'll let me mark this up. Hold on. Let's see if it'll let me load that app. Hold on. I don't know if it's letting me. Here we go. Maybe this is going to work. Yes. All right. How about this? Let's see if this will work. I'm trying this whiteboard app. New whiteboard. All right, let's do this. So what if I go negative? Let's see if it'll let me here. Hold on. Nope. There we go. So if I go negative 1.64, right, equals, I don't know what that cutoff value is, but I do know the mean. And what was your mean again? It was
176.8.
0.7, something like that. And
Yeah.
then what was your standard deviation? 36.
36 point.
Just go to one decimal.
2.
Okay. So if I've got all this, do you know how to solve that for x?
Yes, so you would multiply your negative 1.64 by 46.2.
Good. Can you do that in your
That
calculator
would,
quick?
yeah.
So take 36.2 times negative 1.64, and what do you get?
So on the left would be negative 59.368,
Okay.
and that would equal x minus 176.8.
Cool. I'll make that an 8 then. There we
Or
go.
yeah.
That's all right. That's fine. And now what do we do?
And then we add 176.8 to negative 59.36.8. That will equal
And
x.
yeah, what do you get there?
Let's see. That would be 117.4
Cool.
free.
So I'll draw a little picture here. So there's our mean. Here's kind of our bottom 5%. So we know that cutoff for the bottom 5% is 117.4. So that would be the equivalent of someone that's 117.4 pounds or less is in the bottom 5%. So that's kind of obviously this is not in this discussion, but I'm just kind of showing you how this is kind of the highest level that's in chapter 3 to know.
Okay.
So that calculator comes in handy to both find percentile rank, but it also can help us find z-scores to use this one negative 1.64 if we already know the percentile. Cool?
Yeah.
All right. Is that
Okay.
what you were looking for this morning?
Yes, thank you.
And I think when you start prepping for your test next week, I've got lots of old exams out there for you to look at, and there'll be several practice problems like this for you to try. So there'll be answers and
Wonderful.
everything. So then when you take your test, you should not be surprised on how to do this stuff.
Okay, thank you.
You bet. Well, I'm going to go ahead and stop sharing real quick. All right. So how's that good? Or did you have other things you wanted to talk about besides I mean, I covered hopefully quite a bit, but is that
Yeah,
okay?
that's okay. That's good. That's what I needed to know. So thank you.
Awesome. All right. Well, keep up the good work and request these office hours whenever you think you want one. I'm pretty flexible, so I can usually make it work.
Okay, thank you.
All right. Thank you so much, Madison. You have an awesome day, okay?
You too. Bye.
All right.